Hey everyone, happy Monday. Of course, I'm not there today, but we still need to review for your guys' midterms. So don't forget, midterms, guys, are happening on Thursday and Friday of this week. Thursday, you'll go to periods 1, 2, and 3. So if I have your periods 1, 2, and 3, that's when you'll be taking your midterm. And then on Friday, it'll be periods 4, 5, and 6. So we want to review going back to the first couple of weeks here in January. What we were doing back then was properties of exponents. So that's actually where we're going to start today. So what I need you guys to do is make sure that you guys watch this video, follow along. I'm going to give you guys an opportunity to try some problems on your own. Just try to review. We haven't touched this stuff, again, in quite a couple of weeks here. So please make sure that you guys are putting in the effort. I want to make sure you guys do well on Thursday and Friday. Remember, grades do go out on Friday. So let's just go ahead and jump into it. Properties of exponents. So I don't know if you guys remember, when do we add exponents? When do we subtract exponents? What's anything to the 0 power? What happens if we have negative exponents? Things like that. So let's go ahead and jump into it. So the first two that we talked about when we were dealing with exponents was, one of them was called product of powers. The other one is called power to a power. So what I want you guys to do right now, we're just going to focus on the left right now. So I'll give you guys a quick little review here. Product of powers. Product is just a fancy bougie way to say multiply. So remember, what that means is if you're ever multiplying two things and they have the same base, something like x to the fifth times x to the second. So what I mean by the same base, it's both x and x, and we're taking the product. We are multiplying. Well, what do we simply do with those exponents? We go ahead and we add them. 5 plus 2 is going to give us 7, x to the 7th power. So x to the 5th times x to the 2nd, it is x to the 7th. So what I would like for you guys to do here, take a minute, pause the video, please pause the video. Try these four on your own. Take a minute, see if this was your, if one of these questions showed up on your midterm, would you be ready today? So again, take a minute. When you're ready to see the solutions, go ahead and hit play. All right, so we took a minute and we tried these problems out. So let's go through the solution. So on number one, we are using product of powers. Are we multiplying? Yes, we are multiplying. Do we have the same base? Yes, we have x and x. So what do we do with those exponents? We're simply going to add them. So 7 plus 12 gives us 19. This should say x to the 19th power. That should have been your answer for number one there. All right, moving on to number two. We're still multiplying. We're still taking the product here, and we are multiplying a couple of things, A's, B's, and C's. So basically, you have three individual problems. Think like number one, but three individual problems. I'm going to go ahead and focus on here with just the A's first. A to the 9th times A to the 4th. I'm multiplying. I have the same basis. I'm going to add those together. Well, 9 plus 4 is going to give me 13. This should be A to the 13th power. I'm going to try to change colors here so I can color coordinate for you guys. I move on now to my B's. B to the 3rd times B to the, technically there's a 1 there, so don't forget about that one. 3 plus 1 more gives us 4. This would be B to the 4th power. And again, notice there's no spaces in between the A and the B. There's A to the 13th, B to the 4th, no pluses and minuses, no commas, so be careful. Look at your answer very, very carefully, what you wrote down. And then, of course, the last thing that we're going to multiply here, guys, it's C, right? C to the 1st, technically, times C to the 8th. So 1 plus 8 is going to give us 9. C to the 9th, and there we have it. That is our final answer when we multiply. So we get A to the 13th power, B to the 4th, and C to the 9th. All right, moving on to question number 3. Question number 3, we have just a little bit different here. We do have something called a coefficient. A coefficient is a number in front of a variable. So we have that negative 4 in front of the x times that negative 7 also in front of the x. So those just act like regular numbers. Imagine we covered up the x to the 7th for a minute. Imagine we covered up the x to the 3rd. Let's just take a look at that problem there. That says negative 4 times negative 7. Well, negative times a negative is a positive. 4 times 7 is 28. All right, now let me go ahead and uncover and move on, and let's go ahead and work with our x's now. X to the 7th times x to the 3rd, just like up above. Whenever we're multiplying, we have the same basis. We're going to add those together, and we're going to go ahead and get x to the 10th power. So there is our final answer, 28x to the 10th power. All right, one last one down here. So this is putting a combinations of everything kind of together, multiple variables, and we also have coefficients. So let's actually start there with the coefficients. We have negative 3 times a positive 9. So that alone right there is going to give us negative 27. So again, I do multiply those. Those are just regular coefficients. Those aren't exponents. Let's go ahead and now work with our variables. A to the 5th power. times a to the, careful here, negative 8th power. So remember, we do add them. So what is 5 plus a negative 8? Well, when I combine those, that actually ends up subtracting, and it gives me negative 3. So we're going to write a to the negative 3rd power, and I'll fix that negative here in a minute. This was a little bit more challenging. I wanted to see how ready you guys were. Let's try it one more time, though. B to the negative 4th times b to the 6th. Again, we're still adding those two things together. We have 6 plus a negative 4, really minus 4, so 6 minus 4 gives us 2. That is going to be b to the 2nd power, though. I still don't like that answer. I still don't like that answer. Remember, we hate to have negative exponents, so the way that we quickly fix those, I'm going to go ahead and draw my little fraction line that runs across underneath every one of those things there. And what I need to fix is this part right here. I don't like having a to the negative 3rd. I don't like that it's a negative exponent. So the way that we correct that is we just simply move its position. If it's in the numerator, if it's up above, we're simply going to drop it down. As soon as we drop it down to the bottom, it's going to turn into a positive 3. And again, we're only fixing negative exponents. That 3 is an exponent. This 27 sitting out front, even though it's a negative number, that's a coefficient. That's going to simply stay up above. Negative 27 stays above, and so does b to the 2nd. That should be our final answer. This one was a little bit tricky, but I do want to challenge you guys. I do want to push you guys here. All right, let's go ahead and try the next little shortcut here, which we call power to a power. Their second property of exponents. So what is power to a power? Well, what that means is that you have some base to some exponent. Let's say you have x to the 3rd power. And then in parentheses, we have all of that being raised to another power. Let's say something like 4. Well, whenever you have an exponent, and even that guy has an exponent on top, we simply multiply those two things together. So what's 3 times 4? 3 times 4 is going to give us 12 here. X to the 3rd to the 4th power would technically just be x to the 12th. All right, so what I want you guys to do is the same thing. Take a minute here, guys. Pause the video. Please try the next 4 problems right here. Imagine these showed up on your midterm. Would you be ready for them coming up this week? So whenever you're ready for the solutions, guys, go ahead and hit play. Okay, let's go through it, guys. Let's go through it. So on the first one, very straightforward, kind of like the example we have above. We have x to the 5th, all of that to the 6th power. So power to a power, we multiply them. Well, what's 5 times 6? That gives us 30. This is going to be x to the 30th power. All right, let's move on to the next one here. So for the next one, what you could have done, there's multiple ways to approach this. You could have made 3 copies of everything that's inside, and then it basically would have turned just into a product of powers. Or we can think about it this way. We are going to multiply 3 and 4 here, and this is the part I think normally students get. They say, okay, 4 and 3, power to a power, those are both exponents, so we're going to multiply them. That gives us x to the 12th, but students forget that that's not the only thing in there. That is x to the 4 to the 3rd power, so we do multiply those, but we can't forget about this 3 out in front. This is 3, if you want to think about it this way, this is 3 to the 1st power. You can even multiply that. 3 times 1 is still going to give you 3, so you have 3 to the 3rd power, and I can do better than that. 3 to the 3rd power. What does this mean? What does that mean? That means 3 times 3 times 3. Well, let's actually multiply that out. 3 times 3 is 9. 9 times 3 is 27. I can do better than this. 3 to the 3rd power, I can rewrite this as 27x to the 12th power. That's what we want to see right there. That's what we want to see. All right, moving on to number 3. Here we have a to the 9th, b to the 3rd, c to the 5th, all of that in parentheses to the 2nd power. Again, you could make 2 copies of that, and then it would look like problem number 2 over here, product of powers, or we can simply go through and multiply each one of our exponents by 2. 2 times that 9 there, that would give us a to the 18th. 2 times the 3 here would give us b to the 6th. And then lastly, 2 times 5 here would give us c to the 10th power. That right there would be our final answer. Power to a power, we still end up multiplying. So let's do that one more time. Very similar on the last one here. You're going to multiply 5 with that power of 4, power to a power that's sitting outside. So 5 times 4 does give us a to the 20th power. And then if I do that one more time here, I'm going to try to change colors so it stands out. What's 4 times this negative 2? Well, that's going to give us b to the negative 8. Now, again, I still don't like that answer. I'm still not a fan of it. Just like before, we do have a negative exponent. How do we fix it? Well, let me draw my fraction line there. And put equals. I'm going to draw that fraction bar again one more time. Which of these two needs to move? Which of these two do I need to fix? I need to fix this part right here. B to the negative 8. The 8 to the 20th is fine. That's a positive exponent. I don't need to work with that. I do need to fix this b to the negative 8. Again, right now it's sitting up above in the numerator. All we have to do is drop it down, and it turns into a positive 8. You're just basically switching its position. If that b to the negative 8 was down here in the denominator, I would have kicked it up to the top and I would have made it a positive. Now 8 to the 20th just stays up above, right? That's it in the perfect spot. That does not move anywhere. This is the correct answer that I want to see there. 8 to the 20th power divided by b to the 8th. All right, so there you have it. Product of powers and power to a power. All right, moving on. Quotient of powers. What the heck is quotient of powers? Quotient, again, is just a bougie, fancy way to say divide. What do we do with our exponent, with our powers, whenever we're dividing? Imagine you guys have something like x to the 10th power divided by x to the 7th. Well, whenever you're dividing, and you have the same base, x and x, y and y, b, whatever variables you have, what can we do with those exponents? We're simply going to subtract them. What is 10 minus 7? Well, 10 minus 7 is going to give us 3x to the 3rd power. And again, it's the top minus the bottom, right? So careful. 10 minus 7, so top minus bottom. So one more time, guys, take a minute here with these four examples. Pause the video. Test yourself for a quick minute, right? Copy these down, take a couple minutes, try it out, and then when you're ready to see the solutions, go ahead and hit play. All right. So for question number one, we have 8 to the 9th divided by x to the 4th. I know I'm dividing here, so what do I simply do with those exponents? We're going to take 9 minus 4, which is going to give us 5. This is going to be x to the 5th power, and that is it. All right, moving on. I'm going to go ahead and scoot to the bottom down here. Actually, I'll go down here to the bottom. What's the issue here? Well, right now, I have x's and y's. Why do I want to take a look at that entire problem? All I'm going to focus on is this little section here, right? And it looks like just like the one up above, x to the 9th divided by x to the 4th. This time I have x to the 9th divided by x to the 2nd. So I know I'm dividing. Quotient of power says we're going to simply subtract 9 minus 2 is going to equal x to the 7th power. 9 minus 2 is 7. We're going to do that one more time, but we're going to do that with the y's here. Y to the 3rd divided by y to the 7th. 7 minus 3, be careful there, that is going to give us y to the negative 4th power. 3 minus 7 is negative 4. Remember, you're taking the top minus the bottom, not just because it's bigger, you put it on top. Careful. I got a couple of you guys trying to do that. So again, it's top minus bottom, numerator. Whatever's in the numerator minus that exponent in the denominator. All right, and again, I still don't like this answer. I'm going to draw my fraction bar that runs across the bottom of both of these variables. Which one do I have an issue with? That y to the negative 4th. That's bugging me right now because I do not want to see negative exponents. I need to fix them. Again, it's hovering up above. Let's just drop it down to the bottom. It turns into y to the positive 4th power. That x to the 7th is simply going to stay up top. That does not have to move. Didn't have a negative exponent. It's sitting fine exactly where it's at. All right, moving on to the third one up top here. Same thing, I'm going to focus on just one variable at a time. I see a's and b's. So what is a to the 30th divided by a to the 30th? Well, again, we're dividing, have the same base, a and a, so we're going to subtract those. So 30 minus 30, though, is 0. I'm going to write a to the 0 power for a minute, and I'm going to come back and fix that because there's something special about anything to the 0 power. B to the 16th divided by b to the 12th. Again, we're dividing. Quotient of powers says if you're ever dividing, you have exponents in the same bases. We're going to subtract 16 minus 12, which is going to give us b to the 4th. Now, we can actually take this one step further. We can still continue to simplify this because what do I know about anything to the 0 power? A to the 0 power, anything to the 0 power. This is technically just 1. 1 times b to the 4th is just going to be b